Hello there. Today we'll be going over rotate image. This is a very interesting problem because there are two ways to do this according to the solutions here. The first way is to reverse on diagonal and then reverse left to right. I think this is more of a memorization type solution because when you see this particular problem, when you see rotate these items to the left. Let's say you take this column and you move this column, move it to the right, this column move it down, and this column to move it to below, and this column to move it to the top. As you can see, there's no straightforward way of seeing this particular solution where you do a transpose and then do a reverse where this is equal. By transpose, I mean by shifting these items between 1 and 2 and 6, as you can see here, and flipping them diagonally. Another way to see this is to see how this particular row here, its column becomes a row, and same for all of these columns, they all become rows. So that's what transposing means, and that's exactly what we did here. And we do a reflection by just swapping for each row, swapping each column. And with that, we can provide a particular solution here, which is very neat. However, it is just not very easy to remember sometimes. And that's why we have a separate solution. This is called the rotate group of 4 cells. So what we're doing here is we're rotating. We know that we can rotate this item to here, this item to here, and this item to here, and this item back to here. So by taking this item, we can also do it in reverse. By holding the first item, we store the 1, and then we move the bottom left to the top. So we have a 7 here now. Then we move the bottom right, which is a 9, to the bottom left spot. Then we move the bottom top right spot to the bottom left spot, and we fill in the last spot with the top left to the top right spot here. And that's how we can keep rotating and get this perfect rotation. So this is more straightforward. So let's code that out and work out that solution. Of course, what we're doing here when we're having a multiple layer is that we have to move in to the next layer and then rotate that as well. So this is how it goes. So L and R is equal to 0, and the length of matrix minus 1. So while L and R, we're going to set our top and bottom so that we get our particular matrix, like we have said. So we start here, then it goes into the square. So with that, we just need to do a store top left, and that equals to the matrix of this top item here, which is the top layer, and left plus I, because we will be moving forward. As you can see here, we pulled the second item. So let's take a look at how to move the bottom left to the top right. So bottom left is here, and how the bottom left moves is that it moves upward, and we keep moving upward. So bottom left. So we're going to set the top right. So matrix of top, and L plus I is equal to the matrix of the bottom left. So bottom left, it moves up, so it's going to minus I, and then it's on the most left side. So that's how it's going to stay as L. Okay, great. And then we're going to set the bottom left to top right. So bottom left is now equal to the top right. Bottom left, sorry, bottom left. Bottom right, so bottom right. So the bottom right moves in this way, so that means we store the bottom row and then right minus I. So take the bottom right. I mean bottom left. I mean, where are we? Sorry. I'll move bottom right to bottom left. This is not top. So bottom right, top right to bottom right. So we're looking at the bottom right, and we're looking at top right. So top right, this item moves backwards like this. So we need to do the top. I mean, bottom. Sorry, where are we? Give me a moment. I need to figure out where I'm at. So we did store the top left. We move the bottom left to the top right. Top left. So and then we move the bottom right to top left, and now we're truing move the top right. So top right, where is the top right? So I think what the top right is the 3, and that has to move backwards in this direction, right? Yes. So actually it moves down this way, the top right item. So 3 moves down here, 6 moves down here, yeah, and so on and so forth. Right. Now we just need to move the top left into the top right. And then with that, we can now, oh shoot, forgot. For I in range r minus L, which is this limited amount of space. And oh, then we set the top and bottom. Right. Then we have to reset the right and left because we need to move in. So right is going to minus equals 1 and left is going to plus equals 1 because left goes in 1. So then and the right moves in back 1, and then we go top and bottom moves in as well. And with that, we can run the code. Something's wrong with the insert, and that's why this is occurring. Okay, what's going on? Oh, we're all indented incorrectly. That's no problem. All right, let's submit. This should be good to go. It's a little slow. So this method is definitely slower, but I think during an interview, this is going to be very impressive. I mean, What we're trying to do is show that the interviewer that we know how to solve problems, and this is one problem of many problems. And moving through, I guess, a matrix is one of these problems. So I hope you enjoyed the video. If you did, like and subscribe. If you want more videos, check the link in the description below. I think there's much more learning to be done in terms of coding and moving about in the matrix and doing things like that. And so keep Leetcoding and Neetcoding and leveling up your skills. Thank you very much and have a good one.